This is the quadratic parent function. This is also sometimes called an even power function. The equation for the quadratic parent function is f of x is equal to x squared. F of x means y, so really this says y equals x squared. I want to see what the graph of this one looks like, so I'm going to choose some x's to put into this equation. I'm going to choose x as a negative 1, 0, 1, and 2. Now, if I put negative 1 in place of x in this equation, then it would say that the y is equal to a negative 1 squared. Now, negative 1 squared means negative 1 times negative 1, which would equal a positive 1. If I put in 0 in place of x, then this would say that the y is equal to 0 squared. Now, 0 squared means 0 times 0, so that would be just 0. If I put in 1 in place of x, then this would say y is equal to 1 squared. Now, 1 squared means 1 times 1. 1 times 1 is just 1. And if I put in 2 in place of x, this would say the y is equal to 2 squared. 2 squared means 2 times 2, which is 4. Now I can plot these points. So negative 1, 1, 0, 0, 1, 1, 2, 4. So negative 1, 1. Start at the origin. That means I go to the left 1 and up 1. 0, 0 means I start at the origin. I go over none and up none. 1, 1. Start at the origin. Go to the right 1 and up 1. 2, 4, I go to the right 2 and up 4. I get a general sense of what this graph looks like, but I think it might be helpful to know exactly what's happening over here to the left of the last point that I chose. So I'm going to pick another x value to use. I'm going to add one to my chart here. So I'm going to put in a negative 2. If I put a negative 2 in place of the x, then this would say the y is equal to negative 2 squared, which means negative 2 times negative 2. Well, negative 2 times negative 2 is a positive 4. So that means the extra point that I'm going to plot here is going to be at negative 2, 4. So I'd start at the origin, go to the left 2, and up 4. I get a pretty good idea of the shape of this one. It looks kind of like a U shape. If I continued on, when I went to 3 and I put that in place of x, it would say 3 squared, which is 9. So that means before I get to this next line here, I would have to go all the way up to 9. Same thing on the other side. If I chose negative 3 and put it in, I would get positive 9 again. So before I get to the next line on here, I would have to make it to 9. The shape of this graph is called a parabola. That's an important shape. We'll study it in depth later. Okay, the domain, all the possible x's that I could put into this equation. Since what I'm doing with x is just squaring it, and I can do that with any number, then that means the x's are going to be allowed to be any real number. So I'd say x belongs to the set of real numbers. The y's, however, whenever I take a number for x and I put it in and I square it, the smallest it could ever possibly be is 0. Anything else would be positive. So for the range, the y's are actually going to be greater than or equal to 0. Okay, now looking at increasing, decreasing, and constant. I'm going to move across the graph from left to right and determine whether the curve is going upward or downward. So I'm starting here on the left. As I move this direction, when I actually get to the curve, in order to draw it, I would have to be moving my pen downward, which means it's decreasing. It would continue in that pattern for all of the x's out in this direction. So it's going to be decreasing all the way from a negative infinity up until I get to this point right here, which is an x value of 0. So I'd say it's decreasing from negative infinity to 0. I'm going to use parentheses on either side. That indicates that it's decreasing between those two values, but not actually getting there. A bracket would mean that it's actually touching. Now if I continue on my graph, starting where x is 0 and I move to the right, now in order to draw the graph, I'd have to be moving my pen upward. And that pattern would continue forever also. So that's going to be for x values that are from 0 all the way out until x is positive infinity. So I'd say it's increasing from 0 to infinity. And again, I'm going to use parentheses. Now for constant. For it to be constant, as I move my pen from left to right, I have to be going neither up nor down. And at no point on this graph does it ever actually stay the same from one point to the next. It's always either going up or it's going down. So this graph is never constant. Okay, the things you need to know about the quadratic parent function are the name, the equation, the shape of the graph, the domain, and the range. And of course, if you have the graph, you can figure out the intervals where it is increasing, decreasing, or constant.